show that vector A minus vector B cross vector A plus vector B is equal to 2 times vector A cross vector B. So here, beginning from left hand side, vector A minus vector B cross vector A plus vector B. Now see, cross product is a distributive over addition. So here, taking a cross product of this vector with a vector A and then with vector B, this will be equal to vector A minus vector B cross vector A plus A minus B cross vector B. So cross product is distributive over addition, that is used. Now again, cross product is distributive over addition, so vector A cross vector A minus vector B cross vector A plus vector A. So here we do one by one. Vector A cross vector B minus vector B cross vector B. Now taking cross product of any vector with itself is zero vector. This is plus changing order, vector A cross vector B is minus vector B cross vector A. So that is plus A cross B, this is zero vector. So that is 2 times vector A cross vector B, it is RHS. So LHS is equal to RHS. Now in this question, if either vector A is zero vector or B is zero vector, then their cross product is zero vector. If either vector A is zero vector or vector B is zero vector, then vector A cross vector B is zero vector. This statement is true. This is obviously true. If anyone from A or B is zero, cross product is zero. Now is the converse true? So no. Now next part of question is the converse true? So converse of above statement is not true. Means if cross product is a zero vector, then vector A is zero or vector B is zero vector. So that is converse, it is not true. Because reason is, as for example, we are explaining by example. If vector A is, I am taking vector 2i minus 3j plus k, this is vector A. Vector B, say I am taking multiple of vector A, taking collinear vector, this is A. Now I am taking vector B such that vector A and vector B are collinear. So multiply these scalar components or multiply this vector by any number. Suppose I am multiplying this by 3. So 3 into 2, 6 minus 9 plus 3. So this is not zero vector. This is not zero vector. But if we find cross product of these two vectors, then say first row is ijk, second row is 2 minus 3 1, third row is 6 minus 9 3. So this is equal to, see, I minus 9 plus 9, 0 times I minus j into 6 minus 6, 0 times j plus k into minus 18 plus 18. So it is zero vector. Because these are collinear vector, angle between them is a 0. So we can also calculate cross product of these vectors using a formula magnitude A magnitude B sin theta times n cap. So A is non-zero, B is non-zero, A cross B, it is 0. So here it is clear that A cross B, it is 0 vector. A cross B is 0 vector, but neither A 0 nor B 0. So neither A 0, but neither A 0 nor B 0. So therefore converse is not true. Therefore converse is not true. Write down unit vector in xy plane making an angle of 30 degree with the positive direction of x-axis. Say this is positive x-axis, this is positive y-axis, and this is positive z-axis. So this surface of this green board is suppose xy plane. So this line perpendicular to this surface, it is z-axis that we are showing here in cross. Now a vector which is making angle 30 degree with positive direction of x-axis. So we consider this angle. Suppose OP is making angle 30 degree with a positive direction of x-axis. And because it lies in xy plane, so with y-axis it will make angle 60 degree. And because this vector is in xy plane, it is like this, xy plane OP. And z-axis is perpendicular to this xy plane, perpendicular to this surface. This is z-axis. So angle between z-axis and any vector which lie on this surface is 90 degree. So this vector makes angle 90 degree with this z-axis. So this angle will be 90 degree. This will be we should show like this. This is 90 degree. So here OP is a unit vector in xy plane making angle 30 degree, making angle 30 degree with the positive direction of x-axis. And because it is making angle 30 degree with a positive direction of x-axis, just I explained, it will make, therefore it makes angles 60 degree and 90 degree with positive direction of y and z axis respectively. So these numbers 30 degree, 60 degree and 90 degree are direction angles. Any vector makes angles alpha, beta, gamma with a positive axis, then these angles are direction angles, and direction cosines are So direction cosines are cos alpha, cos beta, cos gamma. So direction cosines of OP are cos alpha, cos beta and cos gamma, that is root 3 by 2 comma 1 by 2 and 0. And because it is a unit vector, these direction cosines are scalar components of that vector. So because OP is unit vector, it will be equal to root 3 by 2 times I cap plus 1 by 2 times j cap plus 0 times k cap, that is nothing. So this is required vector, so which is required vector. Whenever any vector is unit vector, scalar components are always direction cosines of that vector. Now in this question, if vector A is equal to vector B plus vector C, then is it true that magnitude of A is equal to magnitude of B plus magnitude of C? Justify your answer. So say here vector A is equal to vector B plus vector C is given. So if anything we can write, the next is only we are allowed to take magnitude on both sides. This is only the next step which we can write. Vectors are same, so take addition, take magnitude on both the sides. So magnitude of A is equal to magnitude of B plus C. Two vectors are equal vectors, so their magnitudes are equal. Now magnitudes are equal, so we can put magnitude A square is, so to do something after this step, square is required. So magnitude B plus C whole square, so that is equal to magnitude A square is, now this is vector B plus C dot vector B plus C. Magnitude of vector x, square of magnitude of vector x is vector x dot vector x. We are using here property magnitude of vector x square is vector x dot vector x. This property is used. So magnitude of vector x square is vector x dot vector x. So that is magnitude of vector A square is B dot B. So vector B dot vector B plus B dot C plus C dot B plus C dot C. Dot product is distributive over addition. So that is magnitude A square is B dot B is magnitude B square. This is 2 times B dot C, because dot product is commutative. So B dot C is C dot B plus magnitude of C square. Now if now we are doing something here. If angle between vector B and vector C is theta, then B dot C, this can be replaced by magnitude B magnitude C cos theta. It is from a definition of dot product. B dot C is magnitude B magnitude C cos theta if theta is angle between B and C. So putting here in equation 1, putting in 1, magnitude A square is magnitude B square plus 2 times. Now this value is magnitude B, magnitude C cos theta plus magnitude C square. So this is derived result. Now if theta is 90 degree, say from this result, if now I am putting here theta 90 degree, if vector B and vector C are perpendicular vector, we have to put theta 0 degree to check result. To check this result, I am taking theta 0 degree. If theta is 0 degree, then cos theta is 1. Cos theta is 1. So putting in this equation, magnitude A square is magnitude B square plus 2 times magnitude B magnitude C. This is 0. So cos 0 is 1. So I have taken here 1 plus magnitude C square. Therefore, magnitude A square is, now this is the perfect square, magnitude B plus magnitude C whole square. So that means magnitude of A is equal to magnitude of B plus magnitude of C. This is true if angle between vector B and C is 0. If angle between vector B and vector C is 0, then and only then. Now when angle is 0, if vector B and vector C are in the same direction, angle between vector B and vector C is 0, that is B and C are in the same direction. If so, then this is true. This is true. Otherwise, if vector B and vector C are not in the same direction, then magnitude of vector A is not equal to magnitude of vector B plus vector C. So this is the explanation. A vector of magnitude 5 units and parallel to the resultant of vector A and vector B. So here resultant of vector A and vector B, resultant of vector A and vector B is, its addition. So A plus B is, so 2 plus 1 is 3i, 3 minus 2 is plus 1j, minus 1 plus 1, that is 0k. So this is resultant of vector A and vector B. Now we find its magnitude. So its magnitude is square root of 9 plus 1 plus 0, that is square root of 10. Now if we divide this scalar components with magnitude, and whatever we obtain, that will be unit vector in the direction of resultant of A bar and B bar. So here vector A plus vector b, we divide by its magnitude. So this is a unit vector parallel to vector a plus vector b, or in the direction of vector a plus vector b. So after getting unit vector, multiply by 5. So this will be of magnitude 5 in the direction of vector a plus vector b. So this will be the required vector. Required vector of magnitude 5 parallel to resultant of vector a and vector b is obtained by this result. So 5, now say this value is root 10. So divide by root 10. And here I keep vector a plus vector b. So 3i plus j plus 0k. So that is, this will be 15 by root 10i plus 5 by root 10j. So this is required vector. We can simplify it more. So for which here root 5. So it can be simplified as, this is 3 root 5 upon root 2 dividing by root 5. Root 5 times I plus here root 5 upon root 2 times j. So this vector can also be expressed in this different form. So this is required vector. Vector a, vector b and vector c are given. We want unit vector parallel to this vector. So unit vector parallel to any vector, that means divide that vector by its magnitude. So first of all, we find 2 times vector a minus vector b plus 3 times vector c. So this is 2 times vector a is I plus j plus k minus b, so 2i minus j plus 3k plus 3 times c is I minus 2j plus k. So this is given vector, that is, it will be 2i plus 2j, simplifying this, minus 2i plus j minus 3k plus 3i minus 6j plus 3k. So that is, so here 2i minus 2i, this will be cancelled. What is left? 3i. 2j plus j is 3j. 3j minus 6j is minus 3j. 2k minus 3k is minus k. Minus k plus 3k is 2k. Now we find its magnitude. Magnitude of 2a minus b plus 3c. It is equal to square root of 3 square is 9 minus 3 square is 9, 2 square is 4. So it is root 22. Therefore, a unit vector parallel to vector 2a minus b plus 3c is divide with this vector by its magnitude. So divide this by magnitude. That means we divide scalar components by magnitude of that vector. So it is equal to this vector. This vector is 3i minus 3j plus 2k. So this vector, value of this vector is in numerator upon magnitude of this vector is square root of 22. So it is equal to 3 by root 22 times I minus 3 by root 22 times j plus 2 by root 22 times k. So this is required vector. Next question. Show that points A, B and C whose coordinates are given. Show that these points are collinear and find the ratio in which B divides AC. Say here we are given coordinates of A, B and C. Therefore, position vectors of A, B and C are, from coordinates we can put position vectors. Position vector of A is I minus 2j minus 8k, comma. Position vector of B is 5I plus 0j minus 2k, and position vector of C is 11I plus 3j plus 7k respectively. So these are position vectors of A, B and C. Now we find vector AB. Vector AB is, this is A, this is B. So vector AB is B minus A. So 5 minus 1 times I plus 0 minus minus 2 times j plus minus 2 minus minus 8, that is plus 8 times k. So position vector of B minus position vector of A, that is vector AB. So it is 4I plus 2j plus 6k. So it is vector AB. Then we find vector BC. Vector BC is position vector of C minus position vector of B. So that is 11 minus 5 times I, 3 minus 0 times j, 7 minus minus 2, that is 7 plus 2 times k. So it is 6I plus 3j plus 9k. Then vector AC, third vector, vector AC. Vector AC is C minus A, C minus A, terminal point minus initial point. So 11 minus 1 times I plus 3 minus minus 2, that is plus 2 times j, 7 minus minus 8, that is 7 plus 8 times k. So it is 10I plus 5j plus 15k. So these are vectors EB, BC and AC. Now see, we want to show that these points are collinear. See, when 3 points are collinear, means there are 3 possibilities: A dash B dash C, or it can be like this, B dash A dash C, or it can be like A dash C dash B. So these are possibilities for collinearity of these 3 points. So whatever will be the location of points, to show points are collinear, we will show that vector AB and vector BC, AB and BC are having same direction. Vector AB and vector BC having same direction, in which terminal point of this vector is initial point of second vector. So terminal point of first vector is equal to initial point of second vector, and if both are in the same direction, that means points are collinear. So here, if you show vector AB, vector AC like this, if we can show vector AB and vector AC are in opposite direction, means collinear with common initial point. In AB and in AC, A is common initial point. So two vectors are collinear with common initial point. That means points are collinear. Two vectors are collinear in which terminal point of first vector is equal to initial point of second vector, then also collinear. If you check for AC, BC, vector AC, vector BC, see here, terminal points are same. So if terminal points are same and vectors are in opposite direction or in the same direction, means collinear, vectors are collinear with a common terminal point or common initial point, or terminal point of first vector and initial point of second vector are same. So vectors are collinear, hence points are collinear. So this can be proved by showing this location of or this situation of points. So let me check about any two vectors. Let me check for AB and BC. So now I am taking cross product of AB and BC. Cross product of AB and BC, that is here I, J, K. AB 4 2 6, 4 2 6, BC 639, 639. That is, it is equal to, say here 18 minus 18, 18 minus 18, 0 times I cap, plus minus j times 36 minus 36, that is 0 times j cap, plus k into 12 minus 12, that is 0 times k. So it is clear that this is zero vector. So AB cross AC, therefore AB cross AC, AB cross BC is zero vector. Therefore these are collinear. So points are collinear. Vectors are collinear. Vector AB and vector BC are collinear. And in this vector, say terminal point of first vector and initial point of second vector, in which terminal point of vector AB and initial point of vector BC are same, is same. We should say are same. These are same. So therefore vector AB, therefore A, B and C, these points are collinear. It happens if AB and here we have proved vector AB and BC are collinear. and terminal point of vector AB and initial point of BC are same. So this may be the situation of or position of vectors. So therefore points are collinear. Now we want to show that find ratio in which B divides AC. Ratio in which B divides AC. So say here this is B, here A, here C. Position vector of A is here I minus 2j minus 8k, or if we say position vector of A is vector A, position vector of C is vector C, then position vector of point B, we want ratio, find ratio in which B divides AC. So B is suppose vector B. So here if B divides AC in ratio m is to n, if here ratio of division is m is to n, then position vector of B is equal to m into position vector of C plus n into position vector of A upon m plus n. So here in this symbols, vector A, vector B and vector C are position vectors of A, B, C respectively. Now see, putting values in this formula, say here these are vector A, vector B, vector C. Now I am putting values. So say vector B, this is B, 5i plus 0j minus 2k equal to m times C, that is m times vector C. Vector C is 11i plus 3j plus 7k plus n times vector A. So n times vector A is I minus 2j minus 8k upon m plus n. Therefore 5i plus 0j plus minus 2k is equal to 11m plus n I, 11m plus n times I cap plus 3m minus 2n times j cap plus 7m minus 8n times k cap upon m plus n. That is 5i plus 0j minus 2k, it is equal to 11m plus n upon m plus n times I cap plus 3m minus 2n upon m plus n times j cap plus 7m minus 8n upon m plus n times k cap. Now comparing on both sides, 11m plus n upon m plus n is 5, comma 3m minus 2n upon m plus n times 0, comma 7m minus 8n upon m plus n equal to minus 2. That is, this implies 11m plus n is equal to 5m plus 5n. This means 3m minus 2n is 0. 7m minus 8n is minus 2m minus 2n. That means 6m is 4n, comma 3m is 2n, comma 7 plus 2 9m is equal to 6n. So that means this is 3m equal to 2n, 3m equal to 2n, 3m equal to 2n. That means m by n is 2 by 3, m by n is 2 by 3, m by n is 2 by 3. That means ratio is 2 is to 3. This is the required ratio in which B divides AC. Find the position vector of a point R which divides line segment joining two points P and Q, whose position vectors are 2 times vector A plus vector B and vector A minus 3 times vector B, externally in the ratio 1 is to 2. So say here we have P and Q. Position vector of P is 2 times vector A plus vector B. Position vector of Q is vector A minus 3 times vector B. So these are position vectors. Now we want R, point R which divides this line segment in ratio 1 is to 2 externally. So here ratio is 1 is to 2. So here position vector of question is find position vector of point R dividing pic Q, dividing line segment joining pic Q in ratio 1 is to 2 externally equal to. Now say if this is vector P and if this is vector Q, let me say this vector is vector P, this vector is vector Q, then position vector of R is 1 into Q, 1 into vector Q minus 2 into vector P upon 1 minus 2. M times vector B minus n times vector A upon m minus n. Formula for external division: 1 times vector Q minus 2 times, we are taking minus because external division. So that is 1 times vector Q, that is vector A minus 3 times vector B minus 2 times vector P, that is 4 times 2 times this is vector P upon minus 1, that is vector A minus 4A, that is minus 3A, minus 3B minus 2B, that is minus 5B upon minus 1. So this is 3 times vector A plus 5 times vector B. This is the position vector of point R. Now show that P is the midpoint of line segment RQ. Now midpoint of line segment RQ, midpoint of line segment RQ, that is position vector of R plus position vector of Q divide by 2. So position vector of R plus position vector of Q divided by 2. Position vector of R, this is position vector of R, 3A plus 5B plus position vector of Q, it is A minus 3B divided by 2. So this is 4 times vector A, 5 minus 3 is 2 times vector B upon 2. So this is 2 times vector A plus vector B, and it is position vector of point P. So which is position vector of a point P. So what is proved? P is midpoint of RQ. Therefore, P is the midpoint of RQ, line segment RQ. Two adjacent sides of a parallelogram are given by these vectors. Let me take here sides of a parallelogram. This is a parallelogram. Suppose that here O, A, C, B. We are taking parallelogram OACB, in which we are taking this as adjacent sides. Suppose this is 2I minus 4J plus 5K, and this is I minus 2J minus 3K. So in parallelogram OACB, we take vector OA, it is 2I minus 4J plus 5K, and vector OB, these are adjacent sides, that is I minus 2J minus 3K. Now we want a unit vector parallel to its diagonal. This is a diagonal. So we find a diagonal OC. So here diagonal OC, a vector along a diagonal OC. So OC is OA plus AC, or we can say OA plus OB. So it is OA plus OB because these vectors are same. So OA plus AC, that means OA plus OB. So that is OA 2I minus 4J plus 5K plus I minus 2J minus 3K. So that is 2 plus 1 is 3I minus 6J, 5 minus 3 is 2K. So this is a vector along a diagonal. We find its magnitude. Magnitude is square root of 9 plus 36 plus 4. So it is 7. So therefore unit vector parallel to its diagonal is OC. It is equal to, we divide this vector by its magnitude, that is 1 by 7 times 3I minus 6J plus 2K. So this is 3 by 7 times I minus 6 by 7 times J plus 2 by 7 times K. So this is vector, unit vector parallel to diagonal. Now we want area of this parallelogram. Area of parallelogram. And by formula, area is magnitude of cross product of vectors along adjacent sides. Cross product, magnitude of cross product of OA and OB. So let us find cross product of OA and OB. So here I j k vector OA is, that is 2 minus 4 5, 2 minus 4 5, take scalar components, then 1 minus 2 minus 3, 1 minus 2 minus 3. So it is 12 plus 10, 12 minus minus 10, that is plus 10, 12 plus 10, 22i minus j into minus 6 minus 5 minus 11, so plus 11, plus k into minus 4 plus 4 minus 4 minus minus 4, that is plus 4, so 0 times k. So magnitude of this vector is square root of 22 square plus 11 square plus 0 square, that is 22 square 484 plus 121, so square root of this is 4 plus 1 5, 8 plus 2 10, 605, so that is required area. Vector A, vector B and vector C are given. Find a vector D which is perpendicular to both vector A and vector B and its dot product with C is 15. We want to find vector D. So we take vector D. Suppose it is x times I cap, y times j cap, z times k cap. Now here given that vector D is perpendicular to vector A, therefore dot product of vector D with vector A is 0, therefore xi yj zk dot vector A is I plus 4j plus 2k, it is 0. So that is, now taking dot product, x into 1 is x plus y into 4 is 4y plus 2z equal to 0. This is equation 1. We are also given that vector D is perpendicular to vector B. Now we get similar one more equation. D is perpendicular to B, so its dot product with vector B is 0. So xi yj zk dot vector B is 3i minus 2j plus 7k is 0. That is 3x minus 2y plus 7z, this is z, is 0. So this is equation 2. One more equation, it can be derived from this one more property. Now we are also given that dot product of D with C is 15. That means vector C, it is 2i minus j plus 4k, this is vector C. Dot D is x plus y j plus z k equal to 15. Here it is given 15. That is 2x minus y plus 4z equal to 15. This is equation 3. Now we solve these equations 1, 2 and 3. Solving 1, 2 and 3, we can get scalar components of vector D. Scalar components are x, y and z. Now observe these equations. Say Here 1x 2z, here 2x 4z. So if I multiply this equation by 2 and taking subtraction with 3, we can eliminate x and z both. So from 1 and 2, see this equation I am multiplying by 2. So 2x plus 8y plus 4z is 0. This is multiplied by 2. This equation I keep as it is. So doing this we can get coefficients of x and z same. Now taking subtraction, minus plus minus minus. So this is cancelled, 4z is cancelled, 8 plus 1 is 9y equal to minus 15. 9y is minus 15, therefore y is equal to minus 5 by 3. So y is obtained. Y is minus 5 by 3. Now we keep this value in any two equations. So we can get two equations in x and z. So putting this value in 1 and 2. Let me put in 1 and 2. So put in 1 and 2. Here putting minus 5 by 3. So that is x plus 4 into minus 5 by 3, that is minus 20 by 3, plus 2z is 0, that is, this is 3x minus 20 plus 6z equal to 20. So 3x plus 6z equal to 20. That is x 3x plus 6z 20. Let me say this equation number 4. Now we are putting value of y in equation 2. 3x minus 2 into y is minus 5 by 3, that is plus 10 by 3, plus z 7z equal to 0, that is 9x plus 21z equal to minus 10. So this is equation number 5. So these are equations in x and z. So here this was from 1 and this was 3, sorry, it was from 1 and 3, and here we are working in equation 1 and 2. This value we are putting in 1 and 2. So now see here, now this is 9x, this is 3x. So from 4 and 5, this equation I am multiplying by 3. So x can be eliminated. So multiplying this by 3, 9x plus 18z is 60. This equation keep as it is. 9x plus 21z is minus 10. And now taking subtraction. So this will be cancelled. 18 minus 21 is minus 3z equal to 70. So that is 3z equal to minus 70 by 3. So z is 3z is minus 70 by minus 70. So z is equal to minus 70 by 3. Putting this value in equation 4, so from 4, 3x plus 6 into minus 70 by 3 is 20. So therefore 3x minus 140 is 20. that is 3x is 160. So x is 160 by 3. So x is obtained, z is obtained, and y is obtained. Therefore vector D is x times I cap, that is 160 by 3 times I cap, plus y times j cap minus 5 by 3 j, plus z is minus 70 by 3 k. So these values of x, y, z we have substituted in this equation. X, y, z we have taken in this equation. So this is vector D. If vectors A, vector B, vector C are mutually perpendicular vectors of equal magnitude, say here vector A, vector B, vector C are mutually perpendicular, that means vector A dot vector B is 0, vector B, vector C dot product is 0, and vector C dot vector A dot product of vectors, pairwise vectors, is 0 because mutually perpendicular. Equal magnitude, and magnitude of A is magnitude of B is magnitude of C. Suppose that it is K. We suppose each one has magnitude equal, it is K. Now we want to show that vector A plus B plus C is equally inclined to vector A, vector B and vector C. So suppose that vector A plus B plus C, it makes, this vector makes angles alpha, beta and gamma with vectors A, vector B and vector C respectively. This vector makes angles alpha with vector A, beta with vector B and gamma with vector C, that we are supposing. Now first of all, applying formula for these two vectors, see angle between these two vectors is alpha, therefore cos alpha is dot product of these two vectors upon magnitude of vector A plus B plus C into magnitude of vector A. We have formula to find angle between two vectors. If angle between two vectors x and vector y is theta, then cos theta is x dot y upon magnitude x into magnitude y. So applying that result, so that is equal to now see here, taking a dot product A dot A, B dot A, C dot A, then we will have values of magnitude of A plus B plus C. So to substitute values, we will require this value. So first of all, we are finding this value. Now to find this value, magnitude of A plus B plus C, let me find square of its magnitude. So it is equal to vector A plus B plus C dot A plus B plus C. Magnitude of a vector x square is equal to vector x dot vector x, that is equal to vector A dot vector A plus A dot B plus B A dot C plus B dot A plus B dot B plus B dot C plus C dot A plus C dot C, C dot B plus C dot C. That is, it is equal to, now see A dot A, that is magnitude A square, plus A dot B is 0, A dot C is 0, B dot A is 0, B dot B is magnitude B square, B dot C is 0, C dot A is 0, C dot B is 0, C dot C is magnitude C square. So we have used this result 1. So this is from 1. Now magnitude A square plus magnitude B square plus magnitude C square is left. Now this is, each one has value k. So now we are using this value 2. So this is k square plus k square plus k square. So 3k square. So this value we will substitute in this equation. Now again coming in 3. So again from 3, see cos alpha is equal to A dot A plus B dot A plus C dot A. So A dot A plus B dot A plus C dot A upon, this is 3k square, just we keep this as it is, into magnitude of vector A. Now see here, this was value of magnitude of vector A, vector B, vector C, it's a square. It was value of a square of magnitude of vector A plus vector B plus vector C. So vector A plus vector B plus vector C, it is equal to root 3 into k. So this will be used in this relation. Now A bar dot A bar is magnitude A square. This is 0, 0 upon, this is magnitude A plus B plus C upon, this is magnitude A. So that is, now here one magnitude A will be cancelled. So magnitude A upon, this is left. Now this is k, magnitude of A is k, and magnitude of A plus B plus C is root 3 times k. So k is cancelled. So it is 1 by 3. Therefore cos alpha is 1 by root 3. So alpha is cos inverse 1 by root 3. And similarly we can prove by similar procedure, we can find cos beta, cos gamma. So cos beta and cos gamma can be proved 1 by root 3, that is beta equal to gamma is cos inverse 1 by root 3. Therefore alpha equal to beta equal to gamma. So result is proved.